Now let's look at a concrete example of a convolutional neuron or a filter. So a filter or a convolutional neuron is the same thing. Let's say here's our convolutional neuron or a filter. This is one filter. And conceptually, this filter is supposed to detect lines that are slanting, these vertical, maybe slanted lines like these. So the filter is very simple. It only has, let's say here, black represents zeros or something close to zero, and white represents values close to one. So then this is a one. Here's a 0, 0, 0, 1, 0, 0, 0, 1. So my filter has 9 values, and these are the values for my filter. So these are the weights of my filter or my convolutional neuron. And let's say here's my input image. This is my input feature map. Then the output of applying this convolution operation to this image is this. Let's see how. So let's focus maybe on this region of the input image where the intensity of pixels is high over here but very low over here and over here. So if we multiply this 3 by 3 pixel or grid of input with my filter, then the output that I'm going to get looks like this. Because you will see that when 0 multiplies a very high intensity in the first corner, so 0 multiplies the corner here, this 0 multiplies the corner here, and this one multiplies the corner here. Similarly, this 0 will multiply the 1 here, and this 0 will multiply the almost 1 or 0.5 here. So when we multiply, this is what we get. The output that we get looks like this. Now you can see that whenever the input has ones in these regions in the diagonal, then the output is very likely to have a 1. So for 1 pixel, this is what's going to happen. Now, for this reason, all the places where you see there are diagonal lines in the image, diagonal white lines, for example, region like this and region like this, where there are a lot of white diagonal lines, or even region like this, will come out to have very high intensity values in your output. So regions like these and these have very high intensity values because as the filter applies, the filter will start from this corner, right? So it'll start from here, and since all of these are zeros, the multiplication results into a 0. So this actually also becomes a 0, and it keeps multiplying with the input. The filter keeps multiplying with the input one by one, goes back again, it starts at another place and keeps going. So at the end, we get a picture that looks like this. Now this picture, if you compare your input and the output picture, you will see that this filter that we had is checking for diagonal lines of this shape. So anywhere in the picture when we have high patterns that match this diagonal, then the output intensity is high. So effectively, this filter is checking for the presence of high intensity diagonal lines in your input image, and it basically highlights them. So this is how a filter can detect a particular pattern in an input image.